Hello, today we are going to discuss about the techniques of integration or method of integration. We shall have the following techniques of integration. Number one, we talk about integration by substitution or change of variables. Number two, we discuss about integration. Here we use the method of integration by part. So, we are going to start with integration by substitution or change of variables. Substitution method or change of variables. Why do we change variables? Sometimes you can be given an integral and you find it is not simple. So what you do, you simply change variables and you make it simple. By substitution, the variable of integration is changed into another variable so that the integrand is changed into a simple function which is easily integrable. So you change variables to make your integration to be simple. So you are going to do very many examples so that you can understand. Let's do example number one. Find the integral sine power 6 x cos x. Sine power 6 x cos x dx. So we are going to change variables here. We say let t be sine x, and from here we differentiate t with respect to x, and we have dt dx to be equal to cos x. Remember that the derivative of sine is cos, and dt is equal to cos x dx. As you can see, in my original integral I have dx, not dt. So let me make dx the subject of the formula in this expression. Here, dx is equal to dt over cos x. So you are going to replace this one and this one in the original integral. So we get integral will become t power 6. Remember, sine x was equal to t, and our dx is going to be replaced by this one, dt over cos x. Here you can simplify. So finally, I will be having integration t power 6, then dt. As you can see, this integral is in terms of t only. When you are changing variables, make sure that you remain with new variables. So when you are having this one, you apply the other first rule of integration, which states that the integral of u power n du is equal to u n plus 1 over n plus 1 plus c, which means that this one will be, we have integral t power 6, then dt, which is equal to t power 7 over 7 plus c. Remember that we are given our integral in terms of sine and cos, not in terms of t. We use t just to make it simple. As t is equal to sine x, therefore the integral sine power 6x cos x dx is going to be sine power 7x over 7 plus c. So this is the final answer for this example. Let's do another example. Evaluate integral x squared plus 5 bracket power 7 dx. So when you are given such integral, what you do basically here is you take this expression which is in this bracket and you call it another new variable. Let's say t to be equal to x squared plus 5, and you differentiate both sides. it means that dt dx is equal to 2x. From here, dx is equal to dt over 2x. We are going to use this and the one we have before to replace in the original integral. Remember that our original integral was is x into x squared plus 5 power 7 dx. So we have this bracket is a t, we have x, then this will be t power 7, and the dx is going to be replaced by dt over 2x. So dt over 2x. As you can see, I'm going to make sure that all of the variables will disappear and I remain with only new variables. Remember that our new variable is t. Let's simplify this and this. So the new integral in terms of t will be t power 7, then over 2 dt. This one is simple, everybody can do it. So the integral is 1 over 2, then t power 7 dt, which means that the integral is a half, then t power 8 over 8 plus c, and finally the integral is 1 over 16 t power 8 plus c. Remember that t is equal to x squared plus 5, which means that the integral x squared plus 5 power 7 dt is equal to x squared plus 5 bracket power 8 over 16 plus c, which is the constant of integration. Let's do another example. Evaluate the integral cos x e to the power sin x dx. Here we are going to take this sin x as the power of e and we call it a new variable. Let's say let's t be sin x. Differentiating both sides, we get dt dx will be equal to cos x. So let's make ds the subject because we need to replace ds by another thing. So ds is equal to dt over cos x. So our original integral will become e power t, there is cos x, and my dx is going to be replaced by dt over cos x. I simplify cos and cos, I remain with e power t integral dt. Remember that the integral of e power t remains e power t plus c. So therefore the integral cos x e power sin x dx is equal to e to the power sin x plus c. Let's do another example. Calculate dx over x plus 4. What we are going to do here, we are going to take x plus 4 to be equal to t. So dt dx is equal to 1. So dx is the same as dt. So our integral becomes becomes, of course, I want to write it in terms of t, it will be integral dt over t. Remember that the integral dt over t is equal to ln t plus c. Therefore, our integral dx over x plus 4 is equal to ln of x plus 4, then plus the constant multiplication. So let's do also these examples. Evaluate the following integrals. Number 1, for tan x dx. Number 2, tan x, and so on and so on. Let's do number 1. Let's start with number 1. So number 1 is the integral of tan x dx. Remember that the tan is the same as having cos over sin dx. As you can see here, we have a rational function. So what we do, we take this one which is on the denominator and we call it a new variable. Let u be sin x. Let's differentiate both sides with equal to x. Du dx is equal to cos x. Du is equal to cos x dx. And from here, dx is equal to du over cos x. So my integral will become, remember that I have cos x dx over sin x. This one is going to be u, and this one is going to be replaced by that one. So my integral will become cos x times du over cos x divided by u. So the integral is going to be, let's simplify this and this. We are going to have du over u, which is ln of u plus c. Therefore, my integral of tan x dx is equal to ln of, remember that my u is equal to sin x, ln sin x as constant of multiplication. This is the answer for this integral. Number 2, integral of tan x dx. Remember that tan is the same as sin x the same as sin x over cos x dx. Let's say that let t be cos x dt dx will become negative sin x, and the dx will be negative dt over sin x. So x will be replaced by this one, and the cos will be replaced by this one. So our integral will become negative dt over sin x. This one is my dx minus sin x over t, which will be negative dt over t, which is negative nt plus c. Therefore, the integral of tan x dx is equal to negative ln on cos x plus c. This is the answer. You can try this equation. The integral of cos 7x plus 5 dx. This is do it together. We take this bracket and we put it in new variable. 7x plus 5 dt, and from here dt dx is equal to 7. So dx is equal to dt over 7. Let's replace in the new integral. Remaining the original integral, we have our integral will become integral cos t, then dx is dt over 7, which is 1 over 7, then integral of cos t dt, which is equal to 1 over 7, then sin t plus c. Therefore, the integral of cos 7x plus 5 dx is equal to 1 over 7 then sin of 7x plus 5 plus c. We all know how we've been doing this using the formulas. Remember that integral of cos ax plus b is dx is equal to 1 over a, then sin of ax plus b plus, as you can see, if you don't remember this formula, you can use the method of change of variables and you end up with the same equation, the same answer.